In this question, we've been asked to find the area underneath this curve and between the limits -1 and 3. So this is just a standard use of a definite integral. So we're just going to set this up as the integral between our limits, which is between -1 and 3. So the integral between -1 and 3 of our function, which is 3 plus 2x minus x squared. And we're integrating with respect to x, so remember to put your dx on the end. So these terms are all in an integratable form, so we can just go straight into integrating them. There's nothing to do here to make them integratable. I'm just going to put this over here. So remember to put these in a square bracket for a definite integral. So 3 integrates to 3x. So a constant, remember, a number always integrates to the number x. So that goes to 3x. 2x goes to 2x squared divided by 2 using the power rule. And then x squared goes to x cubed divided by 3, also using the power rule. So closing our bracket, moving the limits over to the right hand side, so 3 and -1. And then just checking to see if any of your terms are able to be simplified before subbing in our numbers. So the 3x term, there's nothing we can do with that. This one we can divide top and bottom by 2 to just leave us with x squared. You always want to fully simplify before you sub in your numbers. Nothing we can do with the last one like that. So leaving our limits on there, 3 and -1. So now we're just going to go ahead and process the number, and once we get the final number, that will represent the shaded area. So we're putting the 3 in first, so we're going to get 3 times 3, which is 9, then 3 squared, which is also 9, 3 cubed is 27, 27 divided by 3 is also 9, so a bunch of 9s in this first bracket. Second bracket, remember we're subtracting from the first bracket, we're putting in the lower limit now, so 3 times -1 is -3, -1 all squared is +1, and -1 cubed, be careful with this one, so -1 cubed is -1, but there's a minus in front of that term, so it's going to be a -1, a double negative, to give us a +1 over 3. So this is a calculator question. You could just put this on the calculator at this point. Sometimes it's okay to do that. Sometimes you're better to simplify for a line or two first. So we can see here that 9 minus 9 is 0, so they're going to cancel, leaving just 9 in the first bracket. Don't really need the bracket anymore, but I'll just leave it there. And then in the second bracket, we could sort of add these together. So -3 plus 1 is -2. And then just leave the 1/3. It's up to you how you go about this processing. You could probably put this in the calculator at this point. I'll just do it manually. So we're going to get 9 minus -2, which is 9 plus 2, which is 11. And we've got minus 1 over 3, which is -1 over 3, like this. And then just simplifying these. And again, you wouldn't need to do this because it is a calculator question. You could just put it in the calculator, but this is basically 33 over 3 minus 1 over 3, which comes out to be 32 over 3. Or you could use a decimal equivalent to that if you had put this calculation in the calculator. But either way, because we're representing an area, we need some unit measurement. So we're just going to use a generic units squared because there are no actual units given in the question. So standard thing to do in this question type. So this is the final answer, 32 over 3, or the decimal equivalent of that, units squared. In this question, we've been given these two vectors u and v, and in the first part of the question, we're asked to make the dot product u dot v. So this is just a direct use of the dot product formula on the formula sheet. So this will be part A of our question. And that formula says just to multiply the corresponding components together and then add that all up. So we're going to get u dot v is equal to -1 times -7. So you can go straight to multiplying that. I'll just do it sort of line by line just to show the working. And we're adding to that the y components multiplied together. So 4 times 8. And then finally -3 times 5. So pretty straightforward technique, really, this one. So multiplying those to get a +7 because it's a double negative. These give us a 32, and this is a -15. It is a calculator question. You could do it on the calculator. Sometimes it's quicker actually to do it non-calc. So that would be 39 minus 15, which is 24. So this question is actually more about part B, which is finding the angle between these vectors u and v. But part of the process of finding that angle involves making this number for the dot product. So that's really part of the larger question, although it has been separated out as a question in itself. So we'll use that in part B, and in part B of the question, we're trying to find the angle between these vectors, and we're going to do that using the other formula that's on the formula sheet for the dot product. So the other formula says that u dot v can also be made by taking the magnitude of the vector u, which remember is just the size of the vector, the magnitude or the length of the vector, if it's represented by a line segment, times the vector v's magnitude, so the two magnitudes, multiplied to the cosine of theta, where theta is the angle between the vectors. So it's the theta we're going to be solving for. So if you've got two vectors like this, u and v, let's say they're going this way, so vector u, vector v, and it's important to think about the direction. Remember, vectors are both a magnitude, a length, and a direction. So if the arrows are going that way, then theta is the angle between the positive direction of the vector. So the angle trapped between where the vectors are going away from each other like this, rather than some of the other angles, for example, the angle on the other side. So it's that theta value we're trying to solve for. To do that using this equation, we need this part and we need these parts. So we've already got this part. We've got the 24 that's going to go there. We need these two guys, the magnitudes. So let's maybe just work these up at the side. So the magnitude of u, magnitude formula for a vector is not on the formula sheet, but it's basically Pythagoras. So it's going to be the square root of each of the components in the vector squared added together. So we're going to go minus 1 squared, going to add to that 4 squared and then negative 3 squared. Okay, just like this. So remember your little brackets around the negative numbers, and it is a calculator question, so again you could put this in the calculator. So that's going to be the square root of 1 plus 16 plus 9, and that comes out to be root 26. So just leave that as a root. You don't need to make that into a decimal number. So we'll do the same with the magnitude of v. I'm just going to put that up here just to save a bit of space. So magnitude of v, just plugging into the same formula. So this time we've got negative 7, so that's the first component, squared, add into that 8 squared, and add into that 5 squared. Just to save a bit of time, I did this question earlier, just check the result. So that comes out to be root 138. So you would just put that in the calculator. These numbers are a little bit higher. And again, just leaving that as a root. So these are our two magnitudes. So we're going to be plugging these into the formula and then rearranging it. You can, this is how the formula is presented on the formula sheet, but you can rearrange it at this point because we're trying to rearrange it for cos theta. So if we move the two magnitudes over here by dividing, that would get the cos theta on its own. So that's going to look like cos theta equals u dot v. Remember your little lines, by the way, under the vectors, if they're lowercase vectors, divided by the magnitude of u and the magnitude of v, like this. So this is how it's on the formula sheet, but this is how you're going to use it in practice. So bringing this up here, that would tell us that our cos theta is equal to u dot v, which we know already to be 24, divided by the magnitude of u, root 26, times the magnitude of v, which is root 138. And then we're just going to do cos inverse on this. This is, remember, a calculator question. So cos inverse of this number, 24 divided by root 26, root 138. Just putting that carefully into the calculator. I don't have a calculator, but I did this one earlier, and it comes out to be 66.4 degrees. Okay, and that's basically it. So very standard question that comes up most years on the higher final exam, so definitely a technique to be familiar with. In this question, we've been given this function and we're asked to determine whether it's increasing or decreasing at the point where x equals 2. So that really just means, is the graph sloping up or sloping down at the point where x equals 2? And to determine that, we need to basically work out the gradient and check whether it's positive going up the way or negative going down the way. The gradient and the derivative are essentially the same thing, so this is actually a differentiation question. So we're just going to start by taking our derivative. This is our function. The terms are in differentiable form, so we can go straight into making our f dash x. We're just going to use the power rule, so x cubed differentiates to 3x squared, minus 7x differentiates to just minus 7, and the constant negative 6 differentiates to 0, so that's going to disappear. So that's our derivative. We want to evaluate that at the point where x equals 2, so just substituting in 2 for the x. So that's going to become 3 times 2 squared minus 7. So 3 times 2 squared is 3 times 4, which is 12, minus 7 is 5. So the derivative at the point where x is 2 has come out to be 5. We don't care so much about the number. The 5 represents the gradient at that point. We care about the fact that it's positive. Because it's positive, it tells us the function's graph would be sloping up rather than down at that point. If it was negative, it would be sloping down. So because it's come out to be positive, that tells us the function is increasing. So we just probably need a statement to kind of finish this off, and we'll just say something like f dash 2 is greater than 0, in other words, positive. So therefore, f, the function, is increasing at x equals 2. So really just tying together the concept of the function, the derivative, and the gradient to determine whether a function is increasing or decreasing. Really just means, is the graph going up or is the graph going down? In this question, we've been given this quadratic expression and we've been asked to write it in completed square form. So a pretty standard technique here, but be careful not to jump lines of working. You've got to do these very sequentially and very procedurally. So these are normally set up with the first two terms having a numerical common factor in addition to the x common factor, but the third term not sharing that common factor. So you can only pull out a common factor from the first two terms. Usually it's two even numbers and an odd number, or certainly two numbers that share a common factor like these do, but one that doesn't. So we're going to pull out the common factor of -3. And we're just going to pull that out, like I say, from the first two terms. Good practice to use a square bracket here because we need two brackets in this question. So -3 goes outside. Don't pull out the x additionally as a common factor, just the numerical common factor. So that would leave us x squared, and it needs to be a plus 2x because -3 times plus 2 gives us a -6x. And we're just going to leave the 7 on the end. The end number just kind of hangs out on the end all the way through this question. There is a technique where you can bring it into the bracket, but it causes a lot more problems, so I wouldn't recommend doing that. Now we're going to do the completing the square part. That first part was just factorising using a common factor. We're going to complete the square on the expression x squared plus 2x. So remember, to achieve this, you take half of the coefficient of the x term, so half of 2 in this case, which is +1. If it had been a -2, we would use a -1, so half of 2 is 1. Close the bracket, put a squared on the bracket. If you expanded out that bracket, you would get x squared plus 2x, but you would also get a +1 from the 1 times 1. There is no +1 in the original bracket, so we need to subtract 1 to get rid of that, to compensate for that. So that there and that there are the same thing, just written in a different form. And indeed, each of the lines of working here is the same thing, just written in a different form. That's the whole point. We're trying to turn the original quadratic expression into its equivalent form in the completed square form. So now we're just going to multiply out the square bracket. So we're multiplying -3 to this term, the round bracket, and to this term, the number -1. The -3 cannot multiply into the round bracket because it's got a power on it, so we're just going to put it in front. So the result of multiplying the -3 to the round bracket is just -3 times the round bracket, like that, by sitting in front. And then -3 times -1 gives us +3. We've still got the +7 hanging out on the end. And then our final step is just to add the two end numbers together to give us a +10. So each of these lines of working is equivalent. And in particular, the original quadratic expression and the final completed square form are the same thing, just in a different form. If you multiplied out this bracket and regrouped all the terms, you would just go back to where you started. So very standard technique, comes up most years. Just got to learn to do it very procedurally like this. Some students try and skip lines of working. You can do that, but it tends to end in, well, a mistake. So just doing it very carefully, line by line. In the first part of this question, we've been given these points P and Q, and we're asked to find the equation of the line which they've called L1, which is the perpendicular bisector of the line joining P and Q. So perpendicular bisector is two things. So perpendicular, a right angle, and bisector is another way of saying midpoint. So we're looking for the line that meets this line, P to Q, at a right angle, and meets it not just at any random place, but right in the middle. So we're going to start by making the gradient of the line P to Q, and then we're going to use that to help us get the gradient of the line L1 because they're perpendicular. So gradient of P to Q first. So quite a few parts in this question, so we've just got to take them one at a time. So just using our standard equation for a gradient, y2 minus y1 over x2 minus x1. So 4 minus minus 2, be careful with the double negative there, divided by 3 minus 9. 4 minus minus 2 is 4 plus 2, which is 6, divided by 3 minus 9 is negative 6, and that comes out to be minus 1. So that looks good because you can see the line P to Q is going down the way, so it's down the way to the right, so a negative gradient, so that looks perfect. We want to find the gradient of the line L1, so the m value of L1, because it's at a right angle to this line, it should obey the rule that says that perpendicular gradients multiply together to make minus 1. That's a rule you need to know. So it means that the gradient of the line L1 has to be 1, because if you multiply these together you get minus 1, and that is the criteria. So we've got our gradient. The only other thing we need is a point on the line. To get the point, we're going to use the midpoint. So we're looking for the midpoint of P to Q. So the midpoint can be made using the midpoint formula. And the midpoint formula essentially just says add together your x coordinates and divide by 2, and add together your y coordinates and divide by 2. So we can get this just by, you don't actually need to write out the formula, you can just go ahead and add these. So 3 plus 9 is 12, 12 divided by 2 is 6, and then 4 plus minus 2, that's 4 minus 2, which is 2, divided by 2 is 1. So you don't need to write out the whole formula, just go straight to getting the answer, because it's normally quite straightforward. So that now means we've got a gradient and we've got a point on our line. So we can then go ahead and use the y minus b formula for making the equation of a straight line. So the 6 and the 1 are playing the role of our a and b. So we're going to get y minus the b value, which is 1, equals a gradient, which is 1. Normally you wouldn't write in the 1 for the gradient, but I'm just going to write it in for illustration. X minus the a value, which is 6. And then we're just processing this forward. So y minus 1, multiply the 1 into the bracket, so we get 1x, or x, and minus 6 on the end. And then moving the minus 1 to the other side, so we'll get y equals x minus 6 plus 1, which is minus 5. So that's the equation of our line, perpendicular bisector L1 in the first part of the question, y equals x minus 5. In the second part of the question, we're asked to find the point of intersection between that line, so let me just rewrite it, y equals x minus 5. And the line that they've given us, which I've forgotten, but I'm going to check my notes, which is 3y plus x equals 25. So 3y plus x equals 25. So notice that that second line is not in the correct y equals mx plus c format. So we've got to find where these lines intersect. We can either do that by simultaneous equations, or we can do it more cleverly, I think, by substitution. Substitution means you just take so the y value in the first equation is x minus 5 and substitute that into the second equation. So basically that's the approach I'm going to take here. So replacing the y in the second equation with its value in the first equation. It works just like simultaneous equations and it will give you the same answer. It's just an alternative method. It tends to, in my opinion, work a little bit better. Some people prefer simultaneous equations, and that's absolutely fine. So we're just going to go ahead now, multiply this bracket, gather the terms together and solve the equation. So we're going to get 4x here, 4x minus 15 equals 25. Just being careful with your working, so that would be 25 plus 15 on the other side of the equation, which is 40, giving us x equals 10. So that looks good, doesn't it? It's a nice reassuring two numbers that divide there to give us a nice whole number. That's the x coordinate. We need the y coordinate as well. You could get that by subbing the x into either line. This line's a lot easier, the first one. So we're just going to get y equals 10 for the x value minus 5. 10 minus 5 is 5. So that gives us our full coordinate there, 10, 5. Okay, so that's part B of the question, and then in part C of the question, they're asking us to make the equation of a circle, which just really means that to make the equation of a circle, you need the center point and you need the radius. So they're telling us that this is the center point, so we can say that the center of our circle is at 10, 5, so we've already got that. The only other thing we need to make then is the radius. We're going to make the radius by noting that the distance between C and the point P, this point here, which you can see on the diagram, which I've got over there, point P lies on the edge of the circle, so the distance between the centre and the point P, a point on the edge, is the radius. That's what we're looking for. So we need to work out the distance of C to P. So to do that, we're going to use the distance formula. Distance formula essentially says that you take the square root of the difference between the x coordinates squared and added to the difference between the y coordinates squared. So it's written as x2 minus x1 squared plus y2 minus y1 squared. It's not on the formula sheet. Let me just write down the other point we're interested in here, P, which is the point 3, 4. It's essentially Pythagoras. It is Pythagoras actually. So we're just taking the difference between these. Let me just write it in actually. So it's going to be 10 minus 3 all squared plus 5 minus 4 all squared. And we're just going to go ahead and work that out. So 10 minus 3 is 7. Squared is 49, so we're going to get the square root of 49. 5 minus 4 is 1, 1 squared is 1, so 49 plus 1. So this comes out to be, again, quite a reassuring number, root 50, nice round number. So for our circle, we've got the centre, we've got a radius, and we just need to go ahead and put that into the equation of a circle. The basic equation is the one to use. It's on the formula sheet. And the basic equation of a circle looks like this: x minus a squared plus y minus b squared equals r squared. It's a lot like using the standard equation of a straight line. In the straight line case, you need the gradient and a point. Here you need the center point and the radius, both of which we've already got. So we can just sub in our center point. This is our a value and this is our b value. So we get x minus the a value, which is 10 squared, plus y minus the b value, which is 5, all squared. The radius is root 50. Root 50 squared, the square root and the squared cancel to give us just 50. So that is the final equation of our circle. So quite a good question, that, combining a few different skills and a few different topics. So those are the solutions for that question. In this question, we've been given these two functions, f of x and g of x, and we're asked to make the composites f of g of x and g of f of x. So generally making the composite different ways around, like f of g and g of f will give different results. So in the first part, part A, part 1, we're making f of g of x. So that just means that you're putting the g function inside the f function. So a good way to write it is just replace the g of x with whatever g of x is, which is 2x. You don't have to write that, but it's good practice, I think, to do it like that. And then we're basically just looking at the f function, and everywhere there's an x in the f function, which is only in this one position, or it could be many positions, we're replacing that x with 2x. So it's just going to become 3 plus cos, but instead of x, it's going to be cos 2x. And at that point, we're done. That's all you've got to do with that one. And then in part A, part 2, we're just doing the same thing but the other way around. So this time we're doing g of f of x. So this time we're putting the f function inside the g function. So the f function is 3 plus cos x. So again, good practice to write it like this. And then you're just looking at the g function and saying everywhere there's an x, which again, there's only one of them this time, we're replacing it with 3 plus cos x. So keeping the 2, and then just replacing the x with 3 plus cos x, using a bracket there to separate those out. Then multiplying out the bracket, 2 times 3 gives you 6, 2 times cos x gives you 2 cos x. So you can see these two different directions with the composite f of g and then g of f have given completely different answers, which is generally the case. And then in part B of the question, we're asked to then find the solutions or solution to the equation f of g of x equals g of f of x. So it's not easy to interpret that question. You can see as well that it's also got a range of values given in radians. So it's a bit like, what's going on there? Normally that's to do with trig equations. That should be a clue that it is to do with trig equations. But there is a little interpretation, like how do I set that up? Well, what they're basically telling you to do, and try not to sort of overthink it, they're saying, well, take f of g of x and make it equal to g of f of x. That is literally what they've said in the equation, and then solve that equation. Well, that's not very solvable at the moment, but we know what f and g are. So this is f of g of x. So this is going to be our 3 plus cos 2x, and that's going to be equal to g of f of x, which is 6 plus 2 cos x, 2 cos x, and then we just need to go about solving that equation. That's now turned into a trigonometric equation, very standard one, which has got a double angle term, which we can change using the formulas from the formula sheet, the double angle formulas, and it's got a single angle term, which we're just going to keep. So let's start by changing this according to the formula sheet. So you need to choose the double angle formula for cosine. There are 3 of them, which matches up with the other term. So it's going to be the middle formula, which is the one that says that cos 2x is written as 2 cos squared x. It's actually written with a, not x on the formula sheet, but equivalent in x would be like this. And then on the other side of the equation, we're just going to keep that the same. This has now turned our equation into a quadratic equation, a trigonometric quadratic equation. This is our squared term. This is like playing the role of what would normally be an x term. And then these are our number terms. So because it's quadratic, we need to make it into a trinomial equal to 0. So we need to kind of move the terms around. So I'm going to start with this term, the square term, and write that first, keeping that on the same side of the equation, so nothing really changes with that term. I'm going to bring the 2 cos x term over to make it a minus 2 cos x, and then just gathering our numbers together. So 3 minus 1 is 2, but then bringing the 6 over would be 2 minus 6 to give us minus 4. So I've done that kind of quickly. Just check my work in there if you're not sure. Take a couple of lines of work in yourself if you need to get from there to there. Better to be accurate than to do it super quick. So notice there's a common factor here of 2. We could either pull out that common factor, or much better in my opinion is just to divide by the common factor, because it means there's no bracket, it means there's no number sitting in front, which doesn't play any role in the rest of the question anyway. So dividing this by 2 would just bring it down to cos squared x. Dividing this by 2 would give us minus cos x. Dividing the minus 4 by 2 gives us minus 2. Like this. At this point we have to factorize, so it's a trinomial. These can be quite tricky to factorize. This one's not too bad. So we're going to need, because it's a trinomial, 2 brackets. To make a cos squared term, just like an x squared term, for an x squared you would need an x and an x. For a cos squared x, you'll need cos x and cos x. To make a 2, we need, being a prime number, just 2 and 1. It can only be a 2 and a 1. Doesn't matter where you put the 2 and the 1. We now need to refine it, so it's actually a minus 2. So it's either plus, minus, or minus, plus. We need one of each sign. We've also got to be mindful of making the minus 1 cos x in the middle. So for this one, we would need a minus here and a plus here. So let's just check that. So this times this gives you this. That times that gives you that. Then the middle term, the minus 1 cos x, should be made by a combination of these two and these two. So these two give you a plus 1 cos x. These two give you a minus 2 cos x. Plus 1 minus 2 gives you minus 1. And that's what we're looking for. They're not easy, those. Factorizing is never easy, especially with trig terms. So now we've got it factorized, we're just separating it into 2 little equations. So for the first one, we get cos x minus 2 equals 0 based on that factor. And then for the second one, cos x plus 1 equals 0 based on the second factor. Just like normal quadratic equations, just happens to have trig terms in them. So we'll deal with these one at a time. Remember, we're working in radians. Remember, it's a calculator question if you need that. So cos x here equals 2. Cosine never equals 2, because if you think about the cosine graph, little micro mini cosine graph there, it only goes up to 1 and down to minus 1 as the maximum in values. It never gets to 2. 2 is like way up, way up here somewhere. So never gets to 2, so that means that this first equation has got no solutions. There's no x value such that cos x would equal 2. And that's quite common in these questions, so look out for that. Second equation rearranges to cos x equals minus 1. I'll just use the same diagram. So it gets to minus 1 at this point, which is right in the middle, which is 180 degrees, or pi in radians. And we need pi because we're working in radians in this question. And that's the only solution. There's no other solutions in the range 0 to 2 pi, which is the range given in the question. So pretty standard trig equation there, but just not easy necessarily to get going by the original interpretation of these 2 composite functions. Those are the solutions for that question. In this question, we'd be given this polynomial expression and we're asked to show that x minus 2 is a factor. In other words, to show that x minus 2 divides algebraically into this expression. So we're going to do this by synthetic division. So this is the first part of the question, part A, part 1. So just setting up our synthetic division table just by picking up the coefficients of each of these terms. So 2 and then minus 3. Be careful not to miss the negatives in these questions, which will influence the outcome. So 2 minus 3 minus 3, 2. It's an x minus 2 factor, so that means that a 2, positive 2 goes outside, it's always the opposite sign, remember? So the first number we just pull down, the 2, to give us this, multiplying these together to give us a 4, and then we're adding in the column. So minus 3 plus 4 gives us 1. 1 times 2 is 2, and again just adding. Minus 3 plus 2 is minus 1, and then again multiplying to give a minus 2. So in our final column we've got 2 plus minus 2, which is 0. And that's what we're looking for. Remember, the 0 remainder shows that it's a factor. So maybe just make a little statement. So remainder equals 0. Therefore, x minus 2 is a factor. And then, as is typical in these questions, in the next part, part A, part 2, we're asked to then fully factorize. So this is a cubic expression. The highest power is a 3. That's called the order. So it's order 3. So it could factorize into 3 brackets at a maximum. The order tells you how many brackets you can factorize into as a maximum. So it doesn't have to be 3 brackets, but it likely will be, and that's certainly the most it can be. So we know now the first bracket is x minus 2. We just proved that. We use these numbers, 2, 1, and minus 1. These are known as the quotient. And the quotient allows us to then make a trinomial. So it's going to be 2x squared plus 1x minus 1 as a constant. And this trinomial is what is going to allow us to get the next 2 factors, hopefully. Sometimes that is the full factorization, but in this case, the trinomial should itself split into 2 more brackets. So let's just check that out. So we would need a 2x and an x to make the 2x squared. Because the end numbers are 1, we just need a 1 and a 1. That's the only possible numbers. And then just thinking about the way the numbers need to work out, it would be a plus and a minus here, because to make the middle term, which is a 1x, we need the combination of these two multiplying in these two. So the outer two give you 2x, the inner two give you minus x, so 2x minus 1x gives you plus 1x, and all the other criteria are met. Never easy to factorize trinomials, especially with a number in front, but that is the full factorization there. And just check my work in carefully. So just looking at the question, part B, well, there's a little bit of information between parts A and B, so be careful to read that information. And it's telling us that the 5th term of a sequence is given by u5 equals 2a minus 3. So we're going to need this in part B. So u5 equals 2a minus 3. Okay, so we'll just park that there, and then it's telling us that the terms of a sequence satisfy a recurrence relation, and the recurrence relation, which I'll put here, is in the form un plus 1 equals aun minus 1. So a typical form of a linear recurrence relation. So remember that these n plus 1 and n subscripts, these are just placeholders. What they really tell you is that this number here always needs to just be 1 bigger than this number here. That's all that really means. Can be a little bit confusing, but for example, if that was a 10, that would need to be a 9. If that was a 6, that would need to be a 5. And that's what we're going to need to use in this question. So we're trying to work out the term u7. So we can only work out u7 from u5 by first of all making u6. So we're going to make u6, which is equal to, if this is u6, that will be u5, and we need the a and the minus 1. So it'll be a times u5 minus 1. We know what u5 is. It's this expression here, 2a minus 5. So this is going to be a times u5, 2a minus 5, minus 1, the minus 1 on the end. And then just taking this forward by multiplying out the brackets, 2a times a is 2a squared, a times minus 5 is minus 5a, and then we've just got our minus 1 hanging out on the end. So that gets us to u6. We'll need to then repeat the process to get to u7. So that's going to be a times u6 minus 1. So just using the same formula but changing the subscript numbers. Again, they've got to be sequential. You can't have a gap of more than 1 between these two numbers. So we're just going to plug in a6 this time. We know that a6 is this guy here, so it's going to be a times 2a squared minus 5a minus 1, and then the minus 1 on the end. So we're told in the question what this should come out to be. So just half keeping an eye on where it's hopefully going. I think it looks pretty good because we can see this is going to pick up the cubed term. So this will give us 2a cubed. These two would give us the minus 5a squared. These two will give us the minus 1a, and then the minus 1 on the end. And just quickly checking, that is that what we wanted? That is not what we wanted, but that's because this was meant to be a minus 3, wasn't it? So if I put that back to minus 3 and make that a minus 3, then this would be a minus 3a. This would be a minus 3a. So it just shows you've got to read these questions carefully. So this would end up being a minus 3a squared. So obviously that was a deliberate mistake, just to make sure you're paying attention. So that does then satisfy the answer for part B. And then in part C of the question, we're kind of moving properly into recurrence relations. This is really just algebra more than anything here. And in this part of the question, it's telling us that U7 equals U5, and to determine from that the value of A. So they're telling us that U7 and U5 are the same thing, they're equal. So that's going to have to be important information. We know what U7 is and we know what U5 is. So we can take the equation they've given us but then populate it. So we can actually put in the values. So this is part C, part 1. So U7 is this guy here, the guy that I've just corrected. So that's 2a cubed minus 3a squared minus a minus 1, and that's equal to U5, which is 2a minus 3. And we've got to solve that equation. We'll get to that in a moment, but notice as well they've put in the information between the questions that for that sequence a limit exists. Now they won't put stuff like that in a question without it being important, so it's not just there for random information or to put you off, it's there for some reason. So I'm not sure what we're going to do with that yet, but we'll just leave that for the time being and we'll focus on solving this equation, which is the equation they've basically given us and told us to solve to get A. So it's a polynomial equation, so we need to set it equal to 0. So bringing these terms over to the left. So we get 2a cubed minus 3a squared minus a minus 2a is minus 3a, minus 1 plus 3 is going to be plus 2 equals 0. Now this is a cubic equation, a polynomial cubic equation. It would need to be factorized to be solved. To factorize this, unlike a quadratic equation, we can't really do it manually, we need to use synthetic division, but we don't need to because that is the same expression we had up here, and we've already factorized that in the first part of the question. So that's why these two parts went together. It would be odd to have a polynomial part A and then a recurrence relation part B. They have to be linked. So taking the factors from over here, changing the x to an A, so we get A minus 2, 2a minus 1, and then a plus 1. Okay, so we can then just go ahead and separate these into three mini equations. So we're going to get a minus 2 equals 0, 2a minus 1 equals 0, and a plus 1 equals 0. And just going ahead to solve these, we get a equals 2. For this one, we would get a equals 1 over 2. And for this one, we get a equals minus 1. So we've ended up with three solutions, but if you look in the question, they've said, determine the value of A, not values, value, singular. Singular and plural are super important in higher maths. Loads of questions will guide you as to how many solutions there should be. So how do we whittle down our three solutions to just one? That's where the limit idea comes in. So they're telling us that for the recurrence relation, a limit does exist. So if you've got a generic recurrence relation, which is of the form un plus 1 equals a un plus b, okay, that's a general form, then a limit will exist if the a value, this value here, if it is strictly between minus 1 and 1. So these are our three possible a values, but only this one lies between -1 and 1, so that's the only value for which a limit for that recurrence relation would exist. So we can sort of eliminate these two, and that is going to be our A value. Quite tricky, that, piecing together quite a lot of information that's given in the question. And then finally we're asked to calculate the limit. So again, going back to this generic recurrence relation, for that generic recurrence relation, the limit is given by the formula b over 1 minus a, so the end value divided by 1 minus this value here. So going to our recurrence relation, the b value is -1. We now know the a value is 1/2. So we can make our limit, which I'll just squeeze in down here. Our limit, so b over 1 minus a, is going to be -1 in our case. So the b value is -1 divided by 1 minus 1/2. 1 minus 1/2 is 1/2, so it's -1 divided by 1/2. Divided by 1/2 is the same as times them by 2, so -1 times 2 is -2. And that looks a little unusual for a limit to be negative, but it can be anything. It could be positive or negative. It just depends on the original definition, the original sequence, the recurrence relation as to what the limit will come out to be. So quite a tricky question, that, piecing together quite a lot of parts, techniques and information. So those are the different solutions for the various parts of that question. In part A of this question, we're going to ask to take this trigonometric expression 2 cos x minus sin x and write it in the form k cos x minus a. So this is classic wave function question, very common questions in higher maths. Really application of the addition formula. So we're going to expand this right hand side. So just to back up, good idea to set these equal and then expand this right hand side according to the addition formula. So this becomes k cos x cos a. Remember that for the minus addition formula, that turns into a plus. So it's going to be plus k sine a sine x. So that is just copying carefully what is on the formula sheet. Remember, the formula sheet is written with a's and b's, which is never going to be the case in the questions, which are almost always x and a. So we've made that expansion. It's a good practice just to spin these around to put the a term first. So making this k cos a cos x, and then plus k sine a sine x. And that's really just because x is our variable here, so we always put the variable after the sort of number term, and it just makes it easier to match up in the next part of the question. So we could pull this down here to make it 2 cos x minus sine x, and then we're really just doing inspection. We're matching the left and the right hand side of the equation. So in front of the cos x here, we've got k cos a. In front of the cos x here, we've got 2, so they must be matched up, they must be equal. So we can make a little mini equation. So k cos a equals 2. And the same with the sine, so we're using the sine x term to check what's in front on either side of the equation. So we've got k sine a here on the right hand side in front of the sine x term, and in front of the sine x term here we've got a minus 1. So the minus is really important. You've got to be careful with the plus minus in these questions. So once you've got these two little mini equations, we can then basically make our k value, which is based on Pythagoras. You don't need to show the derivation of this, but it's just going to be these numbers squared added together. So it is actually Pythagoras. We're essentially finding the long side of a right angled triangle. You don't need to show that. So 2 squared is 4, minus 1 squared is 1. That becomes the square root of 4 plus 1, which is 5. So the k value comes out to be root 5. So very, very procedural, these questions, just going through the same sort of process every time. So dividing the sine equation by the cosine equation would give us sine over cos, which is tan. So we get tan a equals the sine number minus 1 divided by the cos number. So that's minus 1 over 2, or minus 1 over 2. We're trying to solve now this trigonometric equation, so we should use a cast diagram. Remember, our cast diagrams need to be based off these two equations in this question type. So the first one is cosine equals a positive value. Let me just put the labels in real quick. So cosine positive value, that would be a check in the first and the fourth quadrants, and then we've got sine negative. Sine positive would be here and here, so sine negative is here and here. So our double tick here, double check, has ended up in the fourth quadrant. So that's where our a value needs to be. Okay, so this is a calculator question. So we're going to go ahead and process this on the calculator. So we're going to do tan inverse of 1/2. So drop in the negative. So tan inverse of 1/2. And this one comes out to be 26.6. So I did that earlier. So 26.6. And that is our A value. That's not our solution though, because, sorry, that's our reference value for getting the A value. Our A value is in the fourth quadrant. So the A value that we're looking for is 360. We're working in degrees in this question, minus 26.6. So that's going to be 333.4 if my calculation there is correct. Let me just check that real quick. So that would be 50, 59. Yeah, I think that's right. So our A value is that. So what does that tell us? Well, that tells us we've got our A value and we've got our K value. So we can then go back to the original thing and we can write that 2 cos x minus sine x is equal to, and remember this is really what these questions are about, just finding the K and the A value. The K value was √5. So it's √5 cos x minus the A value, which we now know is 333.4 degrees. And we're done with that part of the question. Okay, so moving on, I mean, that's classic. That's a very typical question type for part A of a wave function question. Part B's can be a little bit trickier and they vary as to what they're going to ask you. So we're being asked to find the minimum value of the expression 6 cos x minus 3 sine x. So these questions are always, the part B's of these are always linked to the part A. So this obviously looks very similar to what we had in part A, but it's not quite the same thing. So what is the connection between the two? Well, this one has been multiplied by 3 to give us this one. So this is basically equal to 3 times 2 cos x minus sine x. But we know that 2 cos x minus sine x can be written like this. That's what we did in the first part of the question. So it's going to be 3 times √5 cos x minus 333.4 degrees, and then just expanding the bracket to give us basically 3√5 and then that cosine term. So that's us kind of connected the first part of the question to the second part, but the second part is asking us what is the minimum value. So the reason why we've connected these is because you cannot just look at this and know the minimum value. It's a mix of a cosine and a sine function, so there's no way to easily determine that. But if we know that that there and that there are the same thing, then whatever the minimum value of this thing is, then that will be the same minimum value as this, because they're equal. We do know how to get the minimum value of this because it's just a graph transformation of the cosine function. So the cosine function normally has a minimum value of -1, but this is the amplitude value. It's been stretched by 3√5. So the minimum value, value is basically just -1 times 3√5, or you could probably just go straight to minus 3√5. So that is it. That is the minimum value. That's all we're looking for in that part of the question. And then in the final part of the question, so that was part B, part 1. And then in part 2, which is slightly trickier, I think, we're being asked to find the x value for which it occurs. So if you've got a normal, say, cosine graph, which goes like this, is a non-transformed cosine graph, the minimum value is normally -1, and that occurs at this point here, which is at 180 degrees. This, however, remember, is not a normal cosine graph. It's a graph that's been transformed by being stretched up and down the way by this value and then shifted to the right by this value. So that adds 333.4 degrees because those are counterintuitive. The minus actually moves it to the right. So this point, which is normally 180 on our transformed graph, is going to be way over here. It's going to be 180 plus 333.4. That's fine. That would give us the x value we're looking for, but it's outside the range because if you look at the question, it says that value, where does that value occur in the range 0 to 360? So yeah, that would work, but it's outside the range. So what we've got to think about is, well, there's a couple of ways you can think about it, but basically the period of a sine or a cosine graph is 360. So every point that you've got on a cosine graph or a sine graph recurs every 360 degrees. So one way we could do this is we could say, right, the 180, which is where our normal minimum value is going to have 333.4 added to it. That's outside the range, but then we can just take away 360 from that. The other way you could do it is to consider the next minimum value, which would be at minus 180, and then add your 333.4 to that. Because if you imagine the cosine graph going back the way, it goes back the way in the same way it goes forward, and this point is at minus 180. So this point is outside that range, 0 to 360, but it's getting shifted by 333.4 to take it inside the 0 to 360 range. So two different ways to figure these out. They're not easy, to be honest, but the x value we're looking for, I'm going to go for the second method, is minus 180 plus 333.4, and then adding those, calculating those would give us that x value. So yeah, they're never easy how to make those sort of left to right shifts like that. So this would give us, what would this give us? 153 point, let's just check that, 153.4 is it? Something like that. 153.4. So that is the x value that we're looking for that lies in that correct range. So wave function questions, part A, pretty standard. Part B do require a little bit of working, and they vary, but remember they're always linked to part A. So always using somehow your result from part A. We've been given this formula or function for P, which is the perimeter of a sector. There's no diagram given here, so it can be a little difficult to visualize what's going on, but you don't need to worry about that, because if we're trying to find a minimum value, then that is an optimization question, essentially. So it's a differentiation question. So we've got this formula, but we need to think of it as being a function. It's a function for P in terms of x. To find that minimum value, we just need to treat it like an optimization or a stationary point question, differentiate our function with respect to x, set it equal to 0 to solve that equation, and that will give us the x value, which does minimize that P function. So we're just going to start by differentiating it. Notice it's not in a differentiable form, so we'll need to adjust that second term to make it 128x to the minus 1. So this is our P. Then we're going to go ahead and take our derivative. So using the dp dx notation, or you could change the function and write it in terms of P of x like this, but you might need to state that, and then if you wanted to use that notation, you could then make your derivative P dash x. Either should be fine, but probably just going with what's in the question, which would be this way. So the first term, 2x, differentiates just to 2. Second term, using the power rule, will be minus 128x to the minus 2. Anytime these come out to have a negative power, it's always good just to put that back as a positive power. So this would be 2 minus 128 over x squared. So that's just using the reverse of this rule we used to go from here to here. So the whole point now is that once we've got our derivative, we can find that minimum value by setting this equal to 0. But good to make a little statement. So write something like, for minimum values, the derivative, in this case, dp dx is equal to 0. And then we're just going to go ahead and set our derivative equal to 0. So we've got 2 minus 128 over x squared is equal to 0. And we just need to go ahead now and solve this equation. I'm just going to pull it up here. So 2 minus 128 over x squared equals 0. So it's an equation, it's got a fraction in it. We don't like fractions, so we're just going to get rid of that by multiplying each term by x squared. So 2 times x squared is 2x squared. The fraction times x squared, well, remember the fraction is basically saying divide by x squared. Dividing by x squared times of x squared cancel, so we just end up with 128. And then 0 times anything is still 0. We are multiplying the 0 by x squared, but 0 times anything is 0, so it stays as a 0. We need to solve this, so we can divide through by 2 to get x squared minus 64 equals 0. This is a difference of squares, so we can solve this by factorizing. into two brackets. So x and an x, we need an 8 and an 8, 1 plus and 1 minus. And this would give us solutions x equals minus 8 and x equals 8. But in the question, we know that x represents basically a length, it's a radius, so it can't be negative. So we can't take this one forward. That value cannot be the one we're looking for. So we think that it's going to be x equals 8. We need to prove that that will minimize the p function by using a method like a nature table or the second derivative. So I'm going to go ahead and use the nature table. Either way would be fine. Whichever way you've learnt that is going to be okay. Second derivative test doesn't always work, so maybe a nature table is the best way to go. So putting in our value, the second row is going to represent our derivative, so dp dx in this case, and then shape or slope or whatever you want to put in as the third row, something that means shape or slope. Choosing values to the left and to the right. Remember, we're going in numerical order. So 1 to the left of 8 would be 1 would be a good choice. 1 to the right of 8 would be 10. You can use any values you wish that are in the correct range, but just choose sensible values. Because it's a calculator question, it's not quite as difficult, quite as important to get the right values. If it was non-calc, you should definitely use smart values. At 8, the derivative is 0. We know that already, so we can put that in. And we're just going to test these values 1 and 10 in the derivative. So this was our derivative here. So if we put 1 in there for x, we're going to get 2 minus 128 over 1. That's 2 minus 128, which is definitely negative, right? Super negative. If you put the 10 in, you're going to get 2 minus 128 over 100. So that's going to be 128 over 100 is 1.28. 2 minus 1.28 is still positive, so that's going to be positive. So the shape would go like this, which is proof that x equal to 8 does give us a minimum value. X equal to 8 though is not the solution, because the question is asking for the minimum value of p. This is just the value that gives the minimum value. So we need to back substitute into the original formula. So we're going to get that p equals 2 times 8 plus 128 over 8. It is a calculator question. You could go ahead and just pop that in the calculator. I don't have a calculator here, so I'm going to do it in my head. So 2 times 8 is 16. 128 divided by 8, well, 10 times 8 is 80, that would leave 48. So 8 times 6 is 48. So it's going to be 10 plus another 6. So it's also going to be 16, I think. So that's going to come out to be 32. And because we're looking for a perimeter, which is a length, we need units, and the perimeter is given in centimeters, so it's going to be 32 centimeters. Essentially, that is an optimization question, but it doesn't look like one. Optimization questions often have diagrams, quite often some kind of cuboid or something like that. This one doesn't, so it's, I think, easy to misinterpret that question, but that is how we go about finding the solution for P. In this question, we've been given this quadratic equation and we're told that it's got two real and distinct roots. That really just means two roots. And we're asked to determine the range of values of m. So the range of values is always a really important clue in these questions. It means that the m value is not going to be equal to something like m equals 5. It's going to be like m is bigger than something, or m is between two values, like a range of values, like an inequation. So we're told that is two real roots. They've said real and distinct roots. That's just because when you get one real root, you actually get two, but they're the same, so they're non-distinct. So two real roots and two real distinct roots basically means the same thing. So we've got two real roots. So the interpretation of that is that the discriminant for a quadratic equation with two real roots, b squared minus 4ac, would be strictly greater than 0. So that's really the key to unlocking this question. This question is an example of what's called undetermined coefficients in a quadratic equation. So this is really the key. Interpret the root information to the discriminant. Remember, if it had been one real root, the discriminant would be equal to 0. If it was no real roots, it would be less than 0. So we're going to be working with that later on. So let's just start by working up our discriminants. So our a value, the coefficient of the x squared term, is 1. Our b value, which is the coefficient of the x term, is m minus 3. You can maybe put that in a bracket because it's sort of two parts to that. term, and then the c value is just whatever's left over, which is m in this case. So forming our discriminant, so b squared minus 4ac by plugging in those values. So b is m minus 3 all squared minus 4 times the a value, which is 1, times the c value, which is m. Expanding out this bracket, remember to square a bracket you need to sort of think of the bracket twice. If you do expand that out, you would have m times m to give you m squared. You would have minus 3 times m to give you minus 3m, but you would get two of those to give you minus 6m, and then plus 9 because of minus 3 times minus 3. So I'm just thinking of that bracket being written twice, and basically using FOIL, that would then give you this trinomial. Minus 4 times 1 times m is just minus 4m. So just gathering the terms together, m squared minus 6 minus 4 is minus 10m plus 9. So that gives us our discriminant, but we know we want to set our discriminant greater than 0 because of the interpretation of the root information. So we can say m squared minus 10m plus 9 is got to be strictly greater than 0 if the quadratic equation has got two real distinct roots. This has now turned us into a quadratic inequation for us to solve. We'll need to factorize as part of that process, but it is a little different to solving a quadratic equation. So we factorize, we'll need an m and an m, a 9 and a 1 will do the job here, and a minus and a minus. So the way you need to think about these is not just to split it off into two mini equations. You need to sort of, maybe as a bit of side working, imagine that this was set equal to 0. That would then allow you to get roots, and the roots would be m equals 1 and m equals 9. Now, why do we want to do that? Because it allows us to draw a sketch. If you imagine this being the m-axis up here, and then whatever your vertical axis would be, y or something, marking on these 2 points at 1 and 9, bearing in mind that this thing here, this trinomial, this quadratic is a quadratic, so it would make a parabolic shaped graph, which would go something like this. We want where the parabola, where the quadratic is greater than 0. Greater than 0 means above the x-axis, so we're looking at this part here, and that would carry on forever up the way, and the same with this part here. The part we don't want is where it's below the m-axis, I should say. So we want all the m values going this way, like going that way, and all the m values going that way. So for this part here, that's going to be all the m values greater than 9, and for this part here, it's going to be all the m values less than 1. So that's where the range of values that they mention in the question comes from. So that is a solution for that question. In this question, we've been given this function or formula that gives us a percentage of people waiting less than t minutes according to this formula. So this is our percentage, this is our time value, k is just a constant that we're going to find in the first part of the question. So it's a pretty typical setup for these exponential log type equations. I think the story with this one is a little confusing because it brings in like the percentage, and it's, yeah, sometimes the stories are easier than other times, but you just got to go with what they're actually asking you to do. That's what to focus on. And in the first part of the question, what they're actually asking is, hey, if the percentage value is 50 and if the time value is 3, then what is the k value? In other words, can you plug those numbers in and then go ahead and find your k value? So let's just do that. So let's just put a 50 in the place of the p value. Just basically populate in the formula, keep everything else the same apart from the things we're changing, obviously. So k times t, k times 3, that's just 3k. So we're just going to write it like that. So we just need basically now to solve this equation for k. Dividing both sides by 100, so 50 divided by 100 is the same as a half. So it's going to be 1/2 over here. And that gets rid of the 100 here and the bracket. So we're just left with 1 minus this term e to the 3k. If we take the 1 over here, we would have minus 1/2 is equal to minus e to the 3k. We can drop the negative on both of those, and I'm going to spin it around to put my e term on the left, just because the variable is k and that's what we're trying to solve for. So just a quick rearrangement, or you could just imagine moving that over there and moving this over here. To get the k term, the variable k, out of the exponential, we need to use a logarithm. So we're taking the log to base e of both sides. Remember that log with the base c, the natural logarithm as it's called, is shorthanded as ln, and that's the sort of way it's expressed on your calculator. So essentially we're just applying the log to base c, the ln, to both sides of this equation. You can always do the same thing to both sides of an equation. That cancels out effectively the e, so it means that we're left on the left hand side with just 3k, and on the right hand side with ln 1/2. This is going to be a calculator, well, it is a calculator question, so we just do ln of 1/2 divided by 3. No way to do that manually, so you just need to put that in a calculator. So I did this one earlier, and it comes out to be minus 0.231. Minus 0.231. Which is quite typical in these questions for the value up here in the equation, in the power in particular, to be some weird value. So that basically tells us now we can update our formula. So we know now that our original formula is P equals 100, 1 minus, keeping everything the same apart from we've just discovered that K value, so minus 0.231 times T. Okay, and so we're done there with the first part of the question, and we're going to use that new updated formula in the second part of the question. So second part of the question, calculate the percentage of customers who wait for 5 minutes or longer. So essentially that's just asking us to take the t value as 5, plug that into the formula, and that'll give us the percentage. That'll actually give us the percentage of the customers, if you read the question carefully, which is not easy, the percentage of customers who wait less than 5 minutes. We want the customers who are waiting longer than 5 minutes, but whatever percentage we get, we can just adjust it at the end. So we'll chat about that again at the end. Essentially though, we're just putting 5 into the formula, so it becomes 100, 1 minus e to the minus 0.231, so slightly cumbersome number, times the t value, which is now 5. You just got to take your time with these and just sort of make one change per line. You can go ahead and multiply those together, which comes out to be 1 minus 1.155, according to my notes, 155. And then just whatever way you want to process this, you could put this all in the calculator at this point, or you could multiply the bracket like this. It is a calculator question, so you don't need to be, well, you don't try and do too much manually. You can use the calculator. And when you work out all of that, it comes out to be 68.49. So 68.49. We'll just go ahead, I think, and round that up to 68.5. And that's the percentage, so that is the percent. So that's telling us that 68.5% of customers waited less than 5 minutes, because this formula is for the percentage of customers waiting less than t minutes. So if that's the percent that waited less than 5 minutes, then to answer our question, the percentage who wait longer than 5 minutes must be 100 minus this value, 68.5. Okay, so that then comes out to be 31.5? Yeah, 31.5. So 31.5% of the customers would be still waiting after 5 minutes. So kind of normalish sort of log exponential question, that one. Really the key with solving these log exponential equations is the use of the ln. And normally that's got a stronger use than it does in this question, but it is fairly typical. So those are the two solutions for that question. In this question, we've been given these two equations of circles. First one written in the sort of basic form, second one in the general form. We've been given the diagram, which I'll go over there. We've been asked to do various things. There's quite a lot of parts to this question, and you've just got to work through them carefully and sequentially. So the first part of the question is write down the coordinates of the center of C1. So notice that it is a write down question, so there shouldn't be any working involved. These circle equations are on the formula sheet. So the center for this circle is just based on these numbers. So it's going to be it's going to be 13 and minus 4, because the formula is written in general terms x minus and y minus. So the center for C1 is 13 and minus 4. So that's really just interpretation from the formula sheet. So that gives us the centre of C1, and then in part 2 of part A, it tells us that that centre of C1, so this point here, lies on the circumference of C2, and then we've got to somehow work out that C value. So if a point lies on a curve or a straight line or a circle, in this case, any type of function, if it lies on that function, you can substitute it into the function, and that's a valid thing to do. So all we're really doing in this part is saying, well, we know that we've been told that this point lies on this function, so we can sub in the value. So remember, the 13 is the x, the minus 4 is the y, so we're just plugging those in here. So we get 13 squared plus minus 4 squared plus 14 times 13 minus 22 times minus 4 plus c equals 0. There's no real magic to this question, we've just got to process these numbers. So 13 squared is 169 plus 16 plus, what would that be? So 169, 182 I think. And then this becomes plus 88 plus c equals 0. And then if you carry on with that, add these numbers together and then move them to the other side of the equation, you would indeed get that c comes out to be minus 455. So it's really the interpretation there, knowing to plug the x and the y values into the equation. So remember now that that means that we know that this c value is minus 455. So if we have to do anything with a circle, we'll need to use that updated version of the formula by knowing that this value is the one tagged on the end. So sorry, I'm looking off to the side here. I'm just checking what question is coming up next. So in part B of the question, they are saying to determine the ratio in which P divides the line joining the centres. Yeah, not an easy little question, this one. So basically, it might be best to do this with a little sort of diagram. So we've got the radius of the larger circle like this, and then this is the centre point of the larger circle. This is the edge. And then we've got point P, as you can see on the diagram, sort of hanging out somewhere there. And the way we're going to do this is we're going to work out the radius of the two circles. So between here and here, this is the radius of the smaller circle. This between here and here is the radius of the larger circle, just by the geometry. So you can see for the C1 circle, the radius, remember, is just this number squared. So that means that for C1, just put a note up here, for C1, the radius equals the square root of 100, which is 10. For C2, we can get the radius by using the formula. So remember that this value we now know, that the sort of formula for the radius in that general format, according to the formula sheet, is the square root of g squared plus f squared minus c. So like I say, that's on the formula sheet. So in our case, we can get the radius by plugging into that formula. So the square root of, well, this value here is 2g. So g would be 7. So that's going to be 7 squared, otherwise known as 49. And then this value here is the f value. So this is our 2f value according to the formula sheet. So half of that, which is the f value, is minus 11. Minus 11 all squared is 121. So that's plus 121. And then we're taking away from that in the formula the c value, which is minus 455. So that's going to be a double negative. So it's going to be plus 455. If you add that all together, it comes out to be, remember it's a calculator question, you could do that on the calculator, comes out to be 625, and then just taking that square root to give us 25. So that tells us then that here to here, which is from the diagram the radius of C1, is 10. Here to here is 25, because that's the radius of C2. That must then mean that that's 15, 25 minus 10. So the ratio there then is 15 to 10. So the ratio is 15 to 10. You can simplify that though by dividing both sides by 5. Sorry, that was not meant to be a 5. That was meant to be a 3. Dividing both sides by 5 to give us a ratio of 3 to 2. And that looks to be about right, doesn't it? You know, 3 parts there to 2 parts there. Remember, when you're working with ratios, 3 to 2 means you're imagining the line being divided into 5 parts, 3 on one side and 2 on the other. So that is the answer for part B, part 1. Wow, there's so many parts to this question. So part B, part 1. So we'll move on then to part B, part 2. Starting to lose track of all the parts. hence or otherwise determine the coordinates of P. Yeah, not an easy question this either. So we know that this point here is the center point of the larger circle, which we can get by using these numbers, by halving them and taking their negative. That's how that formula works. This is 2g, that's 2f, the center point is minus g minus f, that's from the formula sheet. So the coordinate here is minus 7 and then positive 11, so that's for this point. This point here is the center point of the smaller circle, which is 13 and minus 4. We made that already earlier. So this is 13 and minus 4. So we've got the end points and we know the ratio in which the line is divided by P, and we've got to tie those together to get the point P, the coordinates of P. It's not an easy thing to show working for this, to be honest. So let's just consider first of all the x coordinate. So we know that the x coordinate here is minus 7 and here is 13. P lies somewhere in the middle. Notice the difference between, so I'm going to call it the difference in the x direction between minus 7 and 13 is 20. So the difference equals 20. It's in a ratio of 3 to 2. 3 to 2, like I said earlier, is 5 parts. So if we imagine starting here and we want to figure out how much we've got to add to minus 7 to get to there, well, we're going to have to work out using the ratio, working with that difference of 20. It's a difference of 20, but we're only going 3/5 of the way because we're dividing it into 5 because of the 3 to 2 ratio. 3/5 of the way along that line would give us this point here. So we're going to take basically 3/5 of 20. So 1/5 of 20 is 4 times 3 is 12. So that tells us that between here and here, we're moving 12 units in the x direction. So we're starting at minus 7. So it's going to be minus 7 plus 12, which gives us 5. So the x coordinate of point P is 5. I appreciate that is a little tricky and it's not easy to get your head around, to be honest, but that's how you would need to do it. The similar process will work for the y direction. So the difference between these numbers is 15. Again, we're using the same ratio, so we're using 3/5 of 15. So 1/5 of 15 is 3 times 3 is 9. So the difference between here and here is 9. We're starting at 11, we're going down the way because this is a negative number, so taking 9 away from 11. So in the y direction, we're going to start at 11 and take away 9, and that will land us up at 2. So we've got 5 and we've got 2, so the coordinates of point P are 5, 2. So 5, 2 is what we're looking for. Quite tricky. Okay, and then finally we are looking for determine the equation of the circle C3, and there's some information given about the circle C3. Remember, so this is the final part of the question, part C. Remember, if you're trying to make the equation of a circle, you want to use this basic form of the circle equation, which is on the formula sheet, which looks like this, which essentially just means that you need to find the center point and the radius. So we know that that point P was just found, that is the center point, because we're told that in the information, this is the center point. So that's going to play the role of our A and B. So we can just write that down, that our A, B is equal to 5, 2. So we've got our center point and we just need to make the radius. So from the geometry of the circle, you can see that the radius is going to be the radius of the large original circle, C2. So it's going to be the radius of C2, which was 25, plus the 15, which represents this part here. So point P is the center of our new C3 larger circle. Its radius is going to be 15 plus the difference between there and the edge of the original C2, which is another 25. So 25 plus 15 to give us 40. So a little bit of kind of geometrical reasoning required there. So plugging these values into our formula, and we're going to get x minus the A value, which is 5, all squared, plus y minus the B value, which is 2, all squared, equals 40 squared. You could go ahead and square that and get 1600. So not an easy question that. There's a lot of parts, there's a lot of things going on, but it does ultimately come down to a kind of normal use of the standard formulas for circles and a little bit of geometrical reasoning. This part is quite tricky to do with the ratios. That's actually usually a vector question, so not easy to kind of merge that into a circle question. But these are the solutions for that problem.